Welcome everyone, I'm Thomas, and in this course we will develop some understanding of what complex systems are. Basically, we will cover the notion of complex adaptive system and we'll explain the fundamentals of it. So in this first module, in order to contextualize why is it important to know about complex adaptive systems, we will take a look at some facts about the history of science and technology that really make extremely important to notice that this is something we need to start becoming more aware of. So before understanding, let's raise some awareness. So in this timeline of scientists, you can see our nearly 500 years of history, which actually I recommend this website, Historipedia, where you can see timelines of different types of important humans in history of knowledge, particularly this one. We can see scientists, and if we scroll in and scroll out, we could see more details on specific topics and so on. But this is just a bunch of faces. You can see Descartes, Linnaeus, Galilei, Newton, Goethe, Franklin, etc., which means that along history there has been the development of different branches of knowledge and also the subsequent creation of technologies associated to these scientific discoveries. We can see things, for example, about mechanics, recalling Isaac Newton, or related to biology for Carl Linnaeus, or Marie Curie, who developed a lot of knowledge regarding the structure of atoms, or Einstein, who developed the theory of relativity and so on. Or astronomy with Galileo. So we can see that there are different branches of knowledge developing along history. And this is the first thing that we need to keep clear when we want to start getting close to complex adaptive systems. So please keep in mind that there is a history of technological and scientific development. And in the last, let's say, 350 years, more or less, we have, or 300 years, we have been developing these known industrial revolutions. So the first industrial revolution, which lasted for 120 years, more or less, was created from the development of the steam machine, the steam motor. So the manpower could be replaced by machine power. And this created, of course, the trains, the first trains and so on. Then we had the mass production assembly line electricity. With the discovery of electricity, the mechanization became even more refined. Then we got the computers. Then we got the internet recently, not so recently anymore. And now there is this new transition where human cyber-physical systems are going to be created, and that's understood as the fifth type industrial revolution. So there is something interesting about these industrial revolutions, because this is knowledge that we can see, okay, thermodynamics first, industry 1.0, then we got electricity, then we got computation, then we got complex, let's say, complex systems understanding, or cybernetics, and then we got something which we don't know yet what's going to happen. Cyber-physical systems is the mix between biology and cybernetics, or information. So this is happening now, and we can realize, we can become very aware that this special moment in history is creating knowledge at an unprecedented rate. At no other time in history before was like this in terms of knowledge creation or information transmission. So we need to know just some rough facts. These are not specific numbers, and they change every day actually, but this is a good estimation of, for example, communication spots. We look at 100 years ago, we got telegraphies, or eventually something like a telephone that you can communicate, but there was not even one every square kilometer. So there was one or a few points in every city that you have to go to the post office eventually to send a message. So then we got one point communication spot every, let's say, 10 square kilometers. Then 20 years ago, we had one pretty much at any house. Every house has its own phone. But now, with the creation of the cell phone, we have one communication spot at every single square meter pretty much, because we can be standing at a different square meter, having a phone, and we can communicate. So the number of communication spots, if you see, within the last 100 years have grown like a million times or more. The same with flight routes. 100 years ago, we could only communicate very important cities which have airport, but then the smaller middle-sized cities started having their own airports, and today we have, again, even small cities in Europe, at least in North America and Asia, have small airports. So the flight routes now have grown exponentially as well in a very large number. We can do the same with the access to books, to reading material. Before we have to go to the library, which has an estimate of 500 books you can access at the library, maybe a couple of thousands, but in a small city, maybe 500. Then 20 years ago, we could access to books, but through CDs, CD-ROM or diskettes or whatever way in which we can input information in a computer 20 years ago. But now with the internet, we can access to all the books of the entire history in the same device. Same with videos, with the creation of YouTube and the transmission, streaming of videos. Now we have more hours of recorded time that we could ever even watch. Like in one day, they create like several lifespans of videos. And more interestingly, the number of scientists. The number of scientists 100 years ago was more or less 500. We can think that there was mainly 20, 40, 50 countries with a very well-developed science, but the scientists in each country, the real scientists, there were not so many. 20 years ago, with the creation of universities in the last 80 years and the development of PhDs and so on, we can say we got maybe dozens of thousands. And now we have around 200,000 scientists in the world. So the important thing here is why now? What's going on now? 99% of communication spots have been created in the last 20 years. 90% of the flight routes have been created. 99.99% access to books or video has been gained in the last 20 years. So we now have gained, in the last 20 years, we have gained more access to communicating, to creating and transmitting knowledge, like to 90% of the whole history of mankind. And actually, 90% of human history scientists are alive today. The other 10% was in the entire other 2,000 years of our human history. So now we are creating knowledge at the way that is not even like comparable with what was happening before. So these rough facts get us to make understanding, or very clear, that the complexity of the world is becoming more and more evident because information is transmitting faster. So what is this course about? What do we want to teach you in this course? Is to learn how to recognize a complex adaptive system, because now we are surrounded by this and we must become aware. Now, how to think in terms of complex adaptive systems, which is a little bit more complex than just recognizing, is to understand the features and how the features are interrelated, and also how complex adaptive systems are represented. There are good and bad things for each type of representation, so this is also very important for you to know. So once you have end up watching the series of videos of this course, you will be confident to be able to explain something like this diagram. This diagram encodes a lot of what complex systems are about and the way in which they adapt. We can look, for example, at there is a changing external environment, there is this system, there is a self-organized local relationships that emerge into the complex adaptive behavior, and there is positive feedback and negative feedback in it. So all these concepts and this picture that might look very complicated, at the end of the videos you will be able to easily understand. Starting from any part of the diagram, you will be able to follow up the entire thing with some clarity. So this is what this course is about, and we invite you to continue watching these videos.